Okay. Coming back to the design for Crashworthiness, we have already seen that the main function of the body structure is to protect the occupants in a collision. So we have seen this statement in the last session also, and we have seen. We also told that I also told that there are many standards that we have for a crash test, and even a lot of standards with respect to the performance level as well. And the one what we follow globally is FMVSS, which stands for Federal Motor Vehicle Safety Standards. Okay, shortly called as FMVSS. And you can see the picture here. FMVSS front, where the car with 30 miles per hour is going to have an impact into a rigid barrier. It's a frontal impact, and it is mentioned as FMVSS 208 for a frontal impact. And this is the side impact, where the speed is 33.5 miles per hour impact, and by deformable moving barrier. Okay, so this is a deformable moving barrier. The impact is going to happen by a deformable moving barrier, and the impact can be either with, we can do the impact either with a rigid barrier or a deformable moving barrier. So in the case of the one what is been shown here with respect to the side impact, here is with a deformable moving barrier. And you also have a barrier, it means you also have the FMVSS for a rear impact. You can see the vehicle getting hit by a rear barrier, and the impact speed remains same between the front and the rear. And here we don't have the rigid barrier, but again moving barrier criteria. So you can have n number of combination. Say for example, your vehicle can be moving and you can hit a rigid barrier, or you can also have uh, a moving barrier where your vehicle can be kept stationary in the side impact. And similarly, uh, your vehicle your vehicle is in stationary, and you also have the moving barrier which is hitting at the back. And even you can also have something like the vehicle which is highlighted here, it can move with some miles per hour, and the vehicle which is sitting at the back, okay, which is coming at the back, it can hit the moving vehicle with 30 miles per hour. Even that is also even that case has also been possible. Okay, and the last one is the roof crest. You can see in 216, the name is mentioned as 216. This is the roof. Okay, even the you can also have some load which is acting onto the top of your vehicle. At either say for example this the load acting at the roof top at 5 degree. You can see here, and even this can also act at 25 degree, a various angle. Okay, and here the criteria what we have is the load what it is going to act on the top of the vehicle. The load should be 1.5 times the vehicle weight. Okay, so the overall vehicle weight. Okay, it's not that the roof weight alone. So here the load what you're going to have, it should be 1.5 times higher than the weight. And the criteria here is the deformation. Okay, so you know that the deformation is going to happen. Okay, uh, so the criteria here is the deformation should be less than 5 inches of the deformation. Okay, so this is the criteria that they have for this particular thing. And let us let us see here. You know that the industry of insurance and also the consumer group, they have their own test standard to evaluate the vehicle beyond the standards what has been prescribed by the government norms. Okay, and you know that NCAP, which stands for a new car assessment program, when you take NCAP, you have various norms, procedures, standards which have been set for the vehicle, the car manufacturers and the standards. So, and again, the assessment is based on the probability of the injury during the vehicle getting hit. And this, you also have the rating called the star rating, where you give the rating from 1 to 5, which is based on the probability of getting an injury during the crash, basically. And see, as you said, NCAP stands for New Car Assessment Program. So this is the front barrier. So like this running here is 35 miles per hour, and so it's considered as a full face rigid barrier. And the criteria here is the star rating based on the combination of HAC. So on what basis you are giving the star rating? Okay, you have the rating 1 to 5. It is based on the HAC value, and also the deformation that the dummies is going to experience, or in the case of real accidents, you will have the humans who are sitting at the driver's seat or in the passenger seat. So the deformation that they are going to experience in the chest. Okay. So based on this, you normally give the star rating. And so you see here the percentage of chance of serious injury when you're considering the frontal impact with 35 miles per hour, and the side impact is 33 miles per hour. Okay. And you see here it is based on the probability, as I was telling, which is nothing but a percentage of chance. So when you have the percentage of chance less than 10 percentage, then you give this as a 5-star rating for a frontal impact, and for a side impact uh, less than 5 percentage. See, you will have the injury. It doesn't mean that the probability here says that the percentage of chances for a serious injury. Okay, even that is also very much important, and based on which uh, you give the star rating, basically. Okay. And when you have the high probability of the serious injury for a front and the side, then it becomes only a single star rating. Okay. uh, First we'll see the front barrier. So it is a condition of moving vehicle when the moving vehicle crashes onto a rigid barrier at the front end. Okay, so we have seen the picture in the previous slide, where the front barrier is nothing but the one where the condition of moving the vehicle when it crashes into the rigid barrier. And we will see some of the model with respect to the force, mass, acceleration, and also the time. Okay. So it's very important. See, when we design for any Crashworthiness aspects, so the very important thing that is coming to picture here is the force. Okay, the force at which uh, the impact is going to happen. Okay, what is the force and what is acceleration? Acceleration, and even you call the velocity of your vehicle, and also the velocity of uh, the the vehicle which is coming into picture, or the barrier which is coming into picture. Okay, if it is stationary, it's okay, and if both are moving, okay, you have different velocity. Okay, and even the time required for the impact to take place, even that is also very much important. And again, the final uh, thing it comes here is the deformation. What's the deformation you are going to get after impact? Okay, even that those things also comes into picture here. So let us see the model considering the frontal impact, considering the mass, point mass. You see this is the rigid barrier, and this is the vehicle having the velocity v, and the mass of the vehicle is m. And during the initial period, you know that the time t is equal to 0, and dx by dt is nothing but it's also going to be velocity, because initial velocity is going to be 0, and at the time when you take 0 and when you put the value as 0x for x. Okay. And coming to the model aspects here, when you have some force, what happens? Force is nothing but mass acceleration, and we need to develop the model for this. And when you know this acceleration is nothing but square d square x by dt square, and which is nothing but acceleration, and initial force by mass into acceleration, which is noted as d square x by dt square is equal to force by mass. Okay. And according to this, what happens when you do the integration? This is the velocity dx by dt, and we have a factor called c1. And when you take x is nothing but the displacement. Okay. So when you take the displacement, it's going to be when you look into it, so x is nothing but f by 2m t square plus v0 t plus c2. C2 is again going to be a factor. um, so you have one more characteristics called Crest characteristics. Okay. So again, velocity, when you take the Crest characteristics into picture, you have the velocity into the consideration, and then what is the time required, what is the time interval between the start of the incident to the final crash going to occur or going to finish basically. And you have the efficiency called the Crest efficiency factor. So this is used to consider for a non-uniform crash force characteristics, and you have the formula here. Uh, the formula here is the efficiency is nothing but average force to that of the maximum force which is going to act, and this Crest efficiency factor should be lying between 0 to 1. And this can also be defined as average mass to that of the maximum mass, or the average acceleration, or the maximum acceleration, the ratio of average acceleration to that of the maximum acceleration. Okay, let us see here the displacement, the movement of the vehicle after hitting. Okay, so let us take x-axis as displacement and y-axis as the average force. Okay. So you can see when the force increases, the displacement also increases. Okay. And and once the displacement goes to the maximum level, what happens? The force which is acting also going to get reduced, and finally it comes to the place where the force is going to be 0 and displacement is going to be 0. So this is how the behavior comes into picture. And as I said, the efficiency, which is nothing but the average force, is acting to that of the maximum force. So this divided by f max will give you the Crest efficiency factor, which needs to be lying between 0 to 1. And in case if you do not if you want to consider instead of f average to the ratio between f average to that of f max, you can also consider uh, the acceleration or the mass basically. Okay, let us take a simple example. Considering the vehicle mass, the overall vehicle mass is 1,180 kg when it is impacting a rigid barrier at 55 km per hour. So we are going to solve a problem for a frontal impact, where the rigid barrier, where the impacting velocity is going to be 55 km per hour, and the average crash load is also been given, f average, right? So we have seen what's what is f average and what is f max, and f average is given as 300 kilonewton, and so here we need to calculate what is the crash acceleration, what's the deformation, and a time. Okay, so we know that the acceleration it's going to be a negative force, because you have the crust load acting, so it should be in a negative direction. That means it should be taken as negative. So here the 300 kilonewton is converted to Newton, so 300 to 10 power 3 Newton divided by what is the load, what is vehicle mass. It's going to be 1580 kg. So you know that acceleration is nothing but meter per second square, and so when you do this, you will get the values in meter per second square, and again you need to convert this into g value. What is a g value? Okay, divided by 9.81. Okay, so when you divide this divided by 9.81, you basically you get it as 90.4 g. Okay, so this is the acceleration g level. Or when you put as meter per second square, you can call this as 189.8 centimeter per second square. Okay, and let us talk. Let us see here. In the previous slide, we have seen the formulas, right? So d squared x by dt square. So just you can see here, which is nothing but acceleration, which is defined as a ratio between force by mass, and it should be negative. Okay. Uh, so this is all this is about acceleration and the time taken. So what is the time for a deformation to take place? So we have seen in the last presentation, last slide. So t final, okay, is nothing but mass into initial velocity divided by the force, okay, the crust force basically. So you see here mass is nothing but 1580. Okay, what is the velocity here? Velocity is going to be 55 kilometer per hour, and you need to convert this into meter per sorry per hour into seconds. Okay, so you do it by 3.6. Okay, and you know this already you have 300 into 10 power 3 Newton. So when you calculate this, you get the time. Time is going to be so when you solve this, you'll get 0.0805 second. Okay, so maybe if you want to check, we can check. um, and the last one is what has been asked in the problem. It's a deformation. Again, there is a formula which we have seen in the previous slide. Deformation is nothing but x, which is going to be minus f0 by 2mt square plus v0 into t. And we know the f t square, we have found what is the t here, right? Time, basically time square divided by 2 into mass. In mass would be in kg, and so accordingly you have to see. So if you want to convert to gram or kg, even accordingly units would also will vary. If it is, the unit can be either Newton or kilonewton, so accordingly you should also to take into consideration. And finally you have v0 into t. So v0 we have seen as 55 kilometer per hour, which is you need to convert as a second, so divided by the 3.6 into t's. We have also calculated in the previous formula. So we are going to put this value. So when you put this, what is the deformation that you are going to experience? The deformation what you are going to experience here is 0.614 meter. Okay.